the animations to have an idea of what the designer made. So here I'm just having a preview of the DAE document, so you can see that the DAE file can describe a lot of things. It can describe the 3D objects that are my photo frames. It describes all the lighting information, the movements of the cameras. So everything here is described in the DAE file. So as an engineer, I understand that I want to integrate that in my slideshow application, and that I will have later to replace the two pictures by some photos that comes from my iPhoto library. So let's see how to integrate that into an application. So here is a new, slightly bigger. So here's a new application, a new project that I created from scratch. So there is no code at all yet. So the thing I did was to link with SceneKit in the build phases here. And I added my DAE document to my resources. So here you can see my slideshow.dae in the sidebar of Xcode. So the first thing I will want to do is to edit the interface builder file. So here is my window. And from the interface builder library, I can search for my SCN view that is here. I can drag and drop it into my window. Make it slightly bigger. And the SCN view in Interface Builder comes from with an inspector here that allows you to set some options. For instance, I can directly type the name of the file I want to load at launch. So here I want to load my slideshow.dae. It auto-completes. Okay. And I can also set up a few steps, like I want the animations to play at launch and loop. So here, if I run my application, I see the 3D animation playing in my application. And so this was done without having to write any line of code. So let's switch back to the slides. So you can render a scene into a SCN view if you want to render that in a window with views. But it also provides SCN layers, a SCN layer if you want to render a 3D scene into a layer tree. And a SCN renderer if you want to render the 3D scene into an arbitrary OpenGL context. So that's for loading and rendering a scene. Now you may want to manipulate the objects in your scene to add some interactivity to all that, and that's what I'm going to show now. So first, SceneKit allows you to access all the objects and all the properties of your scene. So you can, of course, move, scale, and rotate the objects in your scene, but you can also add some animations, change the colors or change the textures, adjust the lightings, etc., etc. To do this, you need to know what are the objects, the data structures that describe a 3D scene, and that's what I'm going to show now. So a 3D scene is represented by the SCN scene class, and the SCN scene class has a tree of nodes. A node is represented by the SCN node class, and a tree of node is similar to a tree of layers in coordination or a tree of views in the AppKit. A node has a position, rotation, and scale that define a 3D coordinate system that is relative to its parent node. So it's exactly like a layer that has a frame that represents a 2D coordinate system that is relative to its super layer. So if you want to, for instance, move a node in the 3D space, you just need to set its position to a given vector. So for instance, here I move my node to the origin. I set its position to the vector 0, 0, 0. And managing the hierarchy of nodes is very similar to managing a hierarchy of layers or views with the usual add child and remove from parent methods. Then a node doesn't represent anything in the 3D space. I mean, nothing that can be rendered on the screen. It's just a location in 3D space on which you can attach some attributes. The attributes you can attach to a node are the following. You can attach a camera, you can attach a light, or a geometry. I will explain each of them, but you can already notice that you can share one attribute to multiple nodes. It can be useful if you want to give an attribute to be visible at different locations in the 3D scene at the same time. So let's see the first one, camera. A camera is a point of view that is used by the renderers, so by the SCN view, SCN layer, or SCN renderer. The illustration here shows a single scene rendered by SceneKit, but rendered from different point of views. A camera also has a couple of parameters, like the field of view, for instance, if you want to increase or decrease the perspective effect. The second attribute you can attach to a node are the lights. There are different kinds of lights. For instance, the ambient light is a light that illuminates in every direction, and so it illuminates equally all the objects in the scene. A anomaly light originates from a single point. A directional light illuminates in a given direction. And a spotlight originates from a single point but spreads outward in a cone direction. The lights have a couple of parameters like the attenuation distances, the intensity, the color, etc. But one thing important about light is that it illuminates the entire scene and not only the node it is attached to. The last attribute you can attach to a node is the geometry, and the geometry represents a surface that can be rendered on the screen. The surface is made of triangles that are connected together to build the surface. The triangles are connected to vertices. The vertices have a normal that indicates the direction of the surface. The geometry may have some UVs, sometimes named texture coordinates, that tells how an image should be mapped onto the 3D object. And last, the geometry has an array of materials that defines the final appearance of the surface. Note that it is an array of materials and not just a material, because sometimes the geometry is split into several elements, and each element can have a separate material. So now the materials. The material also defines the appearance of the surface. It is represented by the SCN material class. And the material is made of 8 properties. A property is represented by the SCN material property class. And each property can have a color or an image. The 8 properties of a materials are the following. And the combination of the settings of these 8 properties produce the final appearance of your surface. So for instance, the diffuse here can be considered as the base color of your material. More precisely, it's the color that the material will reflect when it is hit by lights. It can be an image like here, or it can be a simple color if you set an NS color or CG color ref. Then the ambient is the color that the material reflects when it is hit by ambient light only. It can be again an image or a color. The specular and shininess controls the specular highlight of shiny materials. The shininess controls the shape of the specular highlight. Reflective is an image that is used as a reflective environment for your material. The transparent property allows you to define the transparent areas of your material. The normal property allows you to set a normal map, sometimes called bump map, and which is a popular technique to add some details to your surface without having to add more polygons. The multiply property allows you, for instance, to set some light maps or shadow maps, which is a popular technique that designers are familiar with. And last, the emission is an emissive color. That means that it can be visible even when the material doesn't receive any light. So for instance here, the circle image is visible even on the size of the cube that doesn't receive any light, and it's because it is emissive. So with materials we can control how it reacts to light. This can be done with some lighting models that simply support. With a constant lighting model, the constant lighting model doesn't react to any light, just a uniform color. Lambert reacts to light but has no specular highlight. And Blin and Fong have a different specular highlight. So now, to sum up and give an example of all these data structures, let's say I want to change the material of on my object. I will first get the geometry from my node. Then I will create a new material, let's say here a red material, by setting the diffuse contents to the red